Welcome. Today we are going to learn about absorption, which is a gaseous contaminant control technique for air pollution control. So, let us first classify the gaseous contaminants or pollutants. They are classified into two categories: primary pollutants as well as secondary pollutants. As we all know, primary, the name itself suggests that it's emitted directly from a source, which could be a stack or a process equipment. The secondary sources are formed due to the interaction of primary sources, which could be between two primary pollutants, or it could be a primary pollutant and a naturally occurring compound in the atmosphere. Examples of these: sulfur dioxide, sulfuric acid vapors, nitrogen oxide, nitrogen dioxide, carbon monoxide, and other organic compounds, volatiles, hydrogen chloride, hydrogen fluoride, hydrogen sulfide, and total reduced sulfur compounds like your mercaptans and sulfides, and ammonia. So these are the examples of your primary compounds or primary contaminants. Whereas your secondary contaminants are nitrogen dioxide, sulfuric acid, and ozone and other photochemical oxidants. Now here there is a point to be noted that there is no clear sharp demarcation between the primary and the secondary pollutants, because here if you see, few would be found in both the categories. This is possible because the primary gaseous pollutants can participate in a reaction to form the secondary reaction products. So the classification would be either or side as well. Now coming to the next important part, a few of the majorly found pollutants and the description of what they are, including the sources as well as the health impacts caused by these. So, first being carbon monoxide, which is a colorless and a odorless gas, and the sources of which are motor vehicles. You have indoor sources, including kerosene or your wood burning stoves. The health effects are headache, reduced mental alertness, and heart attack. Now, the health effects over here are closely associated with carbon monoxide's property. One of the properties being it combines with the it reduces the oxygen carrying capacity of the blood by combining with hemoglobin, forming carboxyhemoglobin. So this would be a reason for reduction in the mental alertness and certain medical conditions. The second pollutant is sulfur dioxide, which is a colorless gas dissolving in water vapor to form a acid or giving acid rain. Now sources are most of the power industry, that is your coal fire power plants, as well as your petroleum refineries and manufacture of H2SO4 from certain kind of industries like your fertilizer industry. Health effects of the same being eye irritation, chest tightening, lung damage, shortness of breath. Next pollutant being NOx, which is reddish brown, highly reactive gas. It has got a lot of oxides. Now the source of the same being motor vehicles, electric utilities, other industrial and commercial residential areas which are going to burn the fuel. This is also, along with SO2, a major source of the auto exhaust emissions. Now, the effects of the same being irritation of lungs and respiratory symptoms like cough, chest pain, and difficulty in breathing. Now, if you actually see, the health impacts are more or less similar for both of these, because when we talk of SOx, that is SO2 or oxides of sulfur dioxide, oxides of sulfur, and NOx, these come in close association. Next pollutant is your lead, which is a metallic element, which is having the sources as metal refinery, battery manufacturing, and steel producing industry as major prime sources. So over here, health effects are high blood pressure, brain, and kidney damage. So lead is a component which is also found in petroleum, which has been now removed due to a lot of health impacts and negative impacts basically. The last pollutant in the list is your particulate matter, which is nothing but very small particles of dust or other matter, that is tiny droplets of liquids adsorbed on the surface. Sources of the same being diesel engines, power plants, windblown dust, wood stoves, etc. And impacts of the same being eye irritation, asthma, lung damage, and cancer. So now when you are going to design a gaseous contaminant control system, there are few important points or properties to be considered when you are going to design the system for 100% efficiency or maximum to maximum efficiency. So now let us see few of the points. One would be in context of particulate matter, which is talking about the particulate matter characteristic, and second would be the average and the peak concentrations of the same. Both of these play a very crucial role because when the system is being designed, if there is excessive particulate matter present or the particulate matter's characteristics would be such that it would be reactive, corrosive, or it could be quite minute, it could probably cause clogging or certain kind of reactions into the system and damaging the control system. Next, that is your gas stream, average flow rates, and temperatures at the same time peak flow rates and temperatures. So flow rates are important so that you know how efficiently it can work at an average kind of a flow rate as well as at the peak ranges. Same thing with the temperatures. There could be certain gases which could form certain kind of associations or dissociations at elevated temperatures. So temperature is going to be a key module there. So whether you need to elevate the temperature or whether you need to maintain the temperature is very important. Another point over here is certain kind of contaminants or the flue gases which are to be treated could have auto ignition, and this could again damage the system. So that is also one of the characteristics which has been mentioned over here. Also, oxygen being a very important criteria because oxygen, something which could be unoxidized or the oxides of sulfur or something which could be easily combined or converted to some forms which could be less damaging to the environment, are very important, for which the oxygen concentrations have to be maintained. This has got a very close association with the temperatures as well. Contaminant average and peak concentration. So average concentration and peak concentration, because if the concentration is very high and if a system or a methodology like your adsorption or absorption is being used, then in that case the system should be foolproof. If adsorption technique is being used, then the scrubbing liquid which should be there, there has to be a particular contact time. So as we are going ahead, you would be knowing about these in details. Gaseous contaminant control techniques. So there are five major techniques which are being used. These are commercially used everywhere globally. So the first among them is sorption, that is your adsorption or absorption technology. So absorption into the liquids. So you would have your scrubbing liquids or scrubbing liquors, absorption onto the surfaces. Next is your oxidation, that is your biological oxidation, also oxidation or combination in the form of incineration technology. And next is your chemical reduction, so that the toxic compounds are the ones which can cause major impact globally are reduced to the non-toxic compounds and then released into the atmosphere. And condensation of vapors as one of the technique.